Okay, so today we're going to be talking about solving two variable systems algebraically. Our essential question is, what does the solution of a system of linear equations represent? And our target will be to solve systems of linear equations using substitution or elimination. So that's two methods in which we solve systems. You should have done this before in Algebra 1, but we're going to do it again. But that's the reason that we don't list out all the steps, is because this is a review for you guys. But I don't expect you to remember a ton of it until you see it, because it's been quite a while since you've done it. So if you get a single coordinate as your solution, we call this one solution. Okay? That would be one solution. And if you solve your system and you get a true statement such as 0 equals 0, anybody have a guess what that is? Infinite. Good. Infinite solutions. And lastly, if you get a false statement where your variables have completely went away, what would we call that? Good, no solutions. So that part should be a review. Okay. So the next thing we're going to talk about is we're going to do an example of substitution. I'll zoom in for everybody in the back who can't see me back there. Alright. So the first question says solve, and it gives us two equations by substitution. So substitution is when you get one variable alone in one of the equations, and then you can plug that into the other equation. So your goal with substitution is to isolate a variable. Okay? So in this case, which equation would be easier to isolate a variable in?
The second one.
Good, because we don't have to do as much division, right? Because eventually we would have to do division, and we don't have to do this. I'm going to take this equation, and I'm going to solve it for y. So I'm going to get y by itself. So to do that, I'm going to subtract 2x on both sides. And that's going to give me y equals 10 minus 2x. Okay? And these are the same equation. They're just written differently now. So your first thing you want to do is isolate the variable. And when we do that, we now know what y is equal to. And that means that in another equation, if they're a system, I can plug in what I know y to be equal to into that other equation. So I'm going to substitute. So I'm going to take the y right here, and I'm going to replace it with this. So that's going to be 3x plus 4 times 10 minus 2x equals 25. So you take the y and you replace it with what the y is equal to. Once you do this step, you can then just use simplifying a distributive property. That's going to give me 3x plus 40, not 40y, minus 8x is equal to 25. And then you're going to combine like terms. So 3x minus 8x is negative 5x. So I just combine these like terms, and I'm going to subtract 40 on both sides. That's going to give me negative 5x is equal to negative 15. And then I'm going to divide both sides by negative 5, which gives me x is equal to 3. So once you get to this step, we have found part of our solution. Okay? So we figured out that the coordinate is 3 comma something. Anybody know how we could find the y part? Good, we can plug it back into one of the equations, and then we can solve for y. So I'm plugging in for x, which is 3. So that's going to be y equals 10 minus 6, and that means y equals 4. So that would be our solution to the system. Now, anybody know how you could check this? Yeah, we could plug it back into both these original equations and see if they equal each other on both sides. So this one would be 25 equals 25, and this would be 10 equals 10 when you plug these values in. And you could check that on your own. I'm not going to do that right now, but it does work. So yeah. Any questions on this one? No? Okay. Alright, so now we're going to use elimination method. So elimination method is when you basically add the two equations together to try to eliminate one of the variables. Now, oftentimes, when you use elimination, you're going to have to change one of the equations by multiplying it by a constant number, okay, a number basically, all right? So our goal is to cancel out one of these variables. Now, what can I multiply the first equation by that will allow me to cancel out the 3y? Anybody know? -1. Good. So I can multiply the second or the first equation. I'm just going to stick with the first. So I'm going to multiply the first equation by -1. I'm just going to distribute the -1 onto all the terms. That's going to leave me with -5x minus 3y equals 19. And then once I've done that, I'm going to take the second equation and write it below the one I just changed. And then I'm just going to add these two together. So you're just going to combine like terms, which are vertical. So this is going to come out to be 3x. And then what happens to your 3y's? Good. And I'm left with 3x is equal to, what is that, 6?
-6.
Yeah, -6. There we go. -6. So then I'm going to divide both sides by 3. And that's going to give me x equals -2. So now I have x, and now my goal is to find y. So you can pick either equation to plug the x back into to obtain the y. So I just happen to pick the first one, but either one would work correctly here. So I'm plugging in, and I'm just going to simplify. So that's going to give me -10 plus 3y equals -19. I'm going to add 10 to both sides. That gives me 3y is equal to -9. Divide both sides by 3, which gives me y is equal to -3. And like I said, today you don't need to check this because we're doing it together, but if you're on like an SAT or some kind of high stakes test, I highly recommend plugging these back in and making sure your answer is correct. Do you guys have any questions?
No, ma'am.
Okay, moving on then. So once again, we're going to solve by elimination, but this one's a little more tricky because we're going to have to multiply one of these by a fraction. Okay. So here's the way I usually figure out what I'm going to multiply by. So let's say we want to cancel out the y's. Right? We're going to go with that we want to cancel out the y's. So if I want to cancel out the y's, what should this number be if I wanted to cancel it out? What do I want it to be? -3. I would want it to be a -3 because if I add those up, then it's going to cancel out. So I want to find a way to make my -2 become a -3, right? So I have to multiply -2 by some number to get it to -3, right? So I'm going to call that other number n, okay? So I'm going to multiply my -2 by n to make it -3. So in order to solve for n, how can I solve for n here? Good, I could divide by -2, and that gives me n, the number I'm going to use to multiply the equation by, is 3/2, which is also known as 1.5. So that's how you can figure out what number you're going to have to multiply your equation by. So I'm going to have to multiply this first equation by 1.5. And that's the easiest way I found that I can explain it, what you're going to pick. You want to pick a number and see what you want it to get to and set it equal to that times a variable. Okay, we'll do more examples so you can see. I'm going to use the distributive property here. 1.5 times 3, that's 4.5. 1.5 times 2, that's 3. And 1.5 times 4 is 6. I'm doing it in my head, so I think I got it though. And then once I have that, I'm going to bring the other equation down. And then I'm going to add these two equations together. So what's 4.5 plus 5? Good. And then what happens to my 3 y's? Cancel. And that gives me negative 19. And I divide both sides by 9.5. And can somebody double check? I think it gives me a negative 2.
Yeah.
Thank you. So that gives me negative 2. So now that I know what x is, I'm going to use the first equation because it's easier. And I'm going to plug in negative 2. So that's 3 times negative 2 minus 2y equals 4. That's negative 6 minus 2y equals 4. We add 6 to both sides. That gives me negative 2y equals 10. And then I divide both sides by negative 2, which gives me y equals negative 5. Do we have any questions on this so far? Okay. So the next one we're going to talk about. Now, typically you're going to pick the equation with the smaller numbers to multiply something by because it's going to make it easier for you and usually avoid a fraction if possible. So if we want to cancel out the x's here, what should I multiply the first equation by? Negative 2. There we go. Good. So I'm going to multiply this first equation by negative 2. Is any of this coming back to you guys while we're doing this? Okay. Good. And then I'm just going to bring down my second one. I'm going to add them. Now something weird happens here. What happens with the tens? And over here? They also cancel. So I'm left with 0 is equal to 2. What does that mean? No solution. Very good. So if you end up with your variables have all canceled out and you end up with a false statement, we call this no solution. Okay? So does anyone need more time on this one? Okay. So let's try the next one. So anybody want to tell me which equation you think we're going to multiply something by? First or second one? Good, that's going to be easier. And what should I multiply this equation by?
Negative 2.
Not negative 2, but positive 2. Good. So I'm going to multiply the second equation by a positive 2. Distribute. That gives me 8x minus 4y equals 2. And then I'll bring my first equation down. So if I add them together, what do I get for first one? 0 and equals. So does 0 equal 0?
Yeah.
So what's this one going to be? Good. So what this means in reality is if you graph these two lines, these lines would be overlapping each other. Now on the last system, we had a situation where we had no solution. Does anyone know what these two lines would look like on a graph? Parallel, very good. Parallel. So yeah, infinite means they're overlapping. They're actually the equation of the same line. So in reality, if you went ahead and tried to solve these into y equals mx plus b form, you'd actually get the exact same two equations. So the last one we're going to look at is combining your skills of graph solutions and equation solutions together. So they give us the solution, or the equation of a line, and they give us a graph, and they want us to find the solution of the system. So your two options in this case, you could take this line and find the equation of it, or you can take this line and get it into y equals mx plus b form and graph it and compare the graphs. That's the one I'm going to do. So I'm going to take the equation and I'm going to get it into y equals mx plus b. Divide both sides by 4. That gives me y equals negative 1/2 x plus 2. And then I'm going to graph this. So 2. I'm going to go down 1 and over 2, down 1 and over 2. So what do you notice happens here? They're overlapping lines, which means we have infinite solutions. Infinite solutions. So looks like you guys are pretty good with this. So on the homework, a lot of questions are going to be elimination. There's a few substitution ones. And just give your best try. In the future, if you're doing like an SAT, they usually will let you do whatever method you want to do. So